In this episode, you will learn everything you need to know about the language updates you have in the JDK 25. You will learn why these modifications have been made and what you can do with them, and have a glimpse on what is coming next. There are several groups of modifications added since the JDK 21 that you are going to see. The first part is about data-oriented programming. Pattern matching continues to evolve and will continue in the next versions to come. The second part is about how you can design an application in Java. It has to do with the design of the main method, the way you can import classes, and how you can write your own JavaDoc. And the third and last part is about dealing with immutability and null values. So that's quite some ground to cover. Let's get started with pattern matching. As you already know, data-oriented programming is being implemented in the Java platform one step at a time. It started a while ago, and now you have records that you can deconstruct using pattern matching in the context of instance of and switches, and you have CIL types. Switch and instance of were not used much in applications before that, but now switch expressions on CIL types are just awesome. Using them can greatly improve the readability of your code while preserving its robustness and its extendability. On this example, you have a CIL type that models the response from a server. Note that when all the implementing types are members of the CIL types, you do not need to declare your permits clause explicitly, and it's probably the best way to organize your code because your CIL hierarchy needs to live in the same package within your application or in the same module if you use modules, but you probably don't. So having everything located in the same file rather than spread out in different files will probably make your refactoring easier, especially if you have more than one CIL type in your model package. Now that you modeled your server response with this CIL type, you can analyze it with a switch expression using this pattern. Here you have a switch expression. It could also be a switch statement, by the way, and because you are switching on a CILed type, the compiler can check if you forgot a branch in your switch or not, which is much safer than executing the switch, traversing it without actually executing any code, and leaving it. That also works very well if at some point in the future, in the lifetime of your application, you need to add or remove some of your implementation. In that case, the compiler will help you, telling you if there are missing branches in your switch. And as you can see in this code, we use two different kinds of patterns. The first one is a type pattern. Basically, you're asking, is the server response variable of type response? And if it is, create this variable. This variable is called a pattern variable or a binding variable, by the way. And the second one is a record pattern. Here you're asking, is the server response variable of type not found? And if it is, then deconstruct it into its components. So far you can only use deconstruction with records, but the plan is to extend deconstruction to any kind of class. And the JDK will surely benefit from that. Now, if you zoom in the first line of this code, you can see that you could also use a deconstruction pattern. But there is a caveat: you are creating a code pattern variable that you're not using. To find the value of a pattern variable, the accessor is called to make sure that any validation or safety code, like a defensive copy for instance, is properly called. That being said, you can also tell the compiler that you do not need this variable by using the unnamed pattern variable. And in that case, what you're saying is, This response record is built on two components, an int and a string, and I don't need to know what this int is. It makes your code more readable and safer. You cannot do anything with this unnamed variable. If you were giving it a name, you could use it in your code by accident. Using an unnamed variable in this case actually removes one place where a bug could hide. And doing that is always a good thing. Since the accessor of this component is still called, it does not make your code any faster. So don't use unnamed variable for performance reasons. You may be wondering why the record accessors are still called if the result is just thrown away. Well, there are actually several reasons for that. First, records and record patterns were introduced in the JDK 16 and the JDK 21 respectively. And the rule was record patterns call accessors to initialize pattern variables. Then in the JDK 22, unnamed pattern variables are added. As an API designer, you may have designed your record with this strong rule accessors are called in mind, and relied on the fact that the side effects in your accessors are still executed. Why would you do a side effect in an accessor? That's a discussion for another time. But deciding not to call them anymore in some cases would have broken the backward compatibility and could have broken your application. Backward compatibility is paramount in Java, so yes, accessors are still called and your side effects are safe. That being said, if at runtime the JVM can detect that your accessor is not doing any side effect and that the element it returned is not used, then it may decide to optimize things and not call your accessor anymore. But this is a decision that is taken at runtime, not at compile time. You can go one step further and not write the type of the first variable at all. Now, what you're saying is this record is built on two components. The second one is a string, and I don't need to know anything about the first one. There is a subtle difference between the two statements. If you use the first one, and at some time in the life of your application the first component is refactored to a string, for instance, then the compiler will tell you, no, the first component of this record is not an int, now it is a string, and you can update your code accordingly. If you use the second solution, then refactoring the type of the first component will not generate any compiler error. Which one solution should you prefer? Well, it's really up to you to decide. I tend to prefer the first solution since I think it is safer, but it might also be worthless in some cases. By the way, you can also use this unnamed variable in type pattern in that way, and if you do not need several type pattern variables in your switch, then you can even merge the branches together if it fits your need. And if you feel safer using deconstruction with the proper type, as I do, then you can also use it in that way. Great. There are other places where you can use this unnamed variable. Take the following code, for instance, where you are converting strings to numbers. And if it does not work, you just ignore the exception. Well, with unnamed variable, you can save on that and maybe make your code more explicit, since what you declare upfront is that you are not going to do anything with this exception. Note that in that case, you still need to specify the type of the exception you're catching. You cannot use var, nor you can use a simple underscore with no type declaration. You can also use these unnamed variables in lambda expressions. Suppose that you want to store strings of characters in a map, grouped by the length of these strings. You can use a stream and a grouping by to do that, but if you don't want to use the stream API, you can also use a compute if absent in this way. The compute if absent method takes two elements. First, the key you want to add to the map, and a function. If the key is not present in a map, then the function is invoked, and this function takes the key as a parameter, and its result is bound to that key in your map. And by the way, ComputeIfAbsent returns the value bound to that key, whether it has been created just now or a long time ago, which is very convenient in this case, because you just need to add the element in the list that is returned by this method call. This function could actually be a supplier because the key argument is actually known in this code. It's element.length in that case. Why would you need to pass it as an argument? Well, the reason is the following: to avoid this lambda to become a capturing lambda. That is a lambda that captures a local variable. There is a small overhead in the execution of capturing lambdas that is avoided if you pass the key as an argument. So designing ComputeIfAbsent with a function rather than a supplier is actually a performance decision. But what if you do not need the key in the lambda, which is the case here, by the way? Well, you can now use an unnamed variable which tells the compiler, I do not need this argument. Neat. There are several other cases where you can use unnamed variable mentioned in the JEP 456 that I can mention briefly. First, there are cases where you need to read variables, but you're not going to use them. Suppose that you have this method that takes a deck as a parameter. This deck contains the coordinates of points and you need to read them 3 by 3. But it turns out that you only need the first two to create your point instance. So you need to pop the z coordinate even if you do not do anything with it, because if you don't, you will corrupt your queue. In that case, you can use the unnamed variable just to tell the compiler that you are not going to use it. Again, you cannot use this variable by accident in your code. One less place for a bug to hide. You could have written it in that way, where the return value is ignored, but it's probably clearer and more explicit to put it in an unnamed variable. And second, there is an example where you can ignore the variable in the for each pattern. This example may not be the best one you can come with, as you could also call size on the list or count them with a stream, but you get the idea. Suppose now that you need to iterate over the elements of a list, and for some reason, most probably wrong, you want to do some side effects every time you read a new element. Why would you do that? Well, you can write this kind of code to integrate this side effect in the declaration of the for loop. There are some restrictions though. First, you cannot use var to declare the type of your for loop variables. And second, the type of this unnamed variable must match the one of index in this example. Following all this, it is actually legal to write this kind of code, which I found funny. As usual, use this kind of feature wisely. Do not make your code impossible to understand. Side effects make it hard to understand and prevent the JVM from optimizing the execution of your code. So use this kind of pattern only if you do not have any other solution. What does lie in the future of pattern matching? Well, we have a pretty good idea of that, as the JDK 25 brings you a preview feature, which is the support of primitive types. What is it about? Well, as you know, you can check for the type of a variable in Java only if it is a type reference that is an extension of object. And of course, it's not the case for primitive types. So you can't use instance of with int. This code would fail at compile time. With the JEP 507 primitive types in patterns, instance of and switch, it becomes possible. A word of warning though, this JEP is still a preview feature in the JDK 25, so it may change before making it as a final feature. But if you have comments or feedback, it's the right time to bring them to the Amber mailing list. The link is in the description. I would like to shed some light on two examples taken from the JEP itself that I find really interesting. As of now, you can switch on int, and this has always been the case. Suppose you want to analyze the status of an HTTP response. You can write this kind of code, which is nice, but not as accurate as you would like. What if you would like to send a specific message for all the status in the 300 range and another one for the 200 range? To achieve that, you would probably write this kind of code. Using if then else, it's a classical way of writing code, we're used to it, but it's not very readable, cluttered with keywords that are hiding the business meaning of your application. Plus, you have 6 returns, which will make the tools you use to measure the quality of your code yell at you. One way to reduce that would be to use a strategy pattern, which would probably be just painful and certainly overkill. Well, with the support of primitive patterns in Switch, this code can be written in that way. Less keywords to hide your business code, which makes it more readable. There is only one return because this is an expression, and so the readability is much better. You can even push it one step further by using switch on boolean. You may be wondering, why would I switch on the boolean? Well, just take a look at this code. It's stupidly oversimplified, but it's actually already quite complex. It has 2 returns, which is not bad for 4 lines of code. If you write it with a switch on boolean, it gives you this. 1 less line, only 1 return, and better readability. It may look odd as of now, but I'm sure I love this kind of pattern very soon. The second example I would like to show you has to do with the record pattern matching and the conversion between primitive types. It is about analyzing some JSON data. As you know, JSON is a string-based format. There is no number in it, just representation of numbers in the form of string of characters. Suppose that you have the following structure, modeled by the following CIL type. As you can see, a JSON number wraps a double, because this is how JSON works, but your application is dealing with users, and the user record is the following. It has a name and an age, and that age is an int. And of course, you need to convert this double that you have in your JSON number to this int. So you'll probably end up with this kind of code. This would work, but would not handle all the possible errors that you may encounter in your JSON document. Your JSON number wraps a number that could be corrupted or could be invalid, like a negative number. The silent conversion from this double that could be corrupted to an int could actually inject some corrupted data in your application, something that you absolutely want to avoid. Your JSON is supposed to carry an int that has some validation rules, and primitive type pattern matching supports that. So you can write a switch expression that first checks if you have a map, then checks if there is a key called name that is bound to a string, and then checks if there is a key called age bound to a number that can be converted to an int without any loss of precision. That is the important part that is not offered by a simple cast. And then, because you are in the switch, you can check if this int is in the range 0, 130, for instance. And if it's not the case, then you can handle the error as you need. Here, we just throw an exception with a meaningful error message. But you could also check for this JSON number that could not be converted to an int and see what happened. The important point here is that the JSON number record is built on a component that is a double, and you match it to a record pattern that declares an int. This match is successful only if you can convert your double to an int without any precision lost. There is a table in the JEP 507 that defines all the conversion rules between all the primitive types, as there are 7 plus the Boolean type. That makes really 42 rules, plus 14 that are trivial, because you are not going to try to convert a Boolean to an int, right? There has been an effort to make the writing of main methods easier. It started with the JDK 21 on a preview feature called unnamed classes and instance method. It is now a final feature of the JDK 25 and, along with other quality of life elements, greatly simplify several key things in the writing of Java applications. You may be wondering why this is interesting, as if you're working on a server application, like a Spring Boot application, you never write a main method. This method is in your framework, and all the code you write consists in services that are actually callbacks managed by your frameworks. And if you do, you probably use templates or shortcuts in your IDE, type main, and the rest is written for you. But you still need to create the class that will carry this method. The first step is to simplify the main method by allowing this syntax: no more public static, no more parameters. Of course, the old syntax is still supported, and in case you want to write both in the same class, that would be really naughty. The classical static one takes precedence. And you can even go one step further by even removing the name of the class. So the simplest Java application you can write is just that, void main, in a .java file, and here you go. And this is your first Java program, so of course you need to write hello world, because reasons? Well, you do not need to invoke this cryptic system.out field anymore. You can just call println from the IO class added to make things easier. Note that this class, which is a regular Java class, lives in the java.lang package, so no need to import it. If you are not in an IDE, how can you run this application? Well, here again, some simplification has been made. All you need to do is to type java application.java, that's the name of the file where you save this code, and the JVM can run it for you directly. Yes, you do not need to invoke javac anymore. The compilation is done for you by the JVM. In this case, where you invoke the JVM directly, no class file is actually generated. So every time you run your application, your code is recompiled from scratch. And it's probably a good thing, because if you're just experimenting with small pieces of code, this is probably what you want. But if what you're doing is actually using this feature to run script-like applications, then you need to keep in mind that you will have longer launch times. If you ever played with this feature with the JDK 21, you may remember that there was a limitation. All your source code had to be in the same file. Well, this is not the case anymore. This limitation has been lifted in the JDK 22, and that's actually not exactly new. But you can reference classes that are in the default package in the same directory, and in that case, the discovery of these classes is automatic. Or you can reference external libraries by playing with the class path that you can pass as a line argument to the launching of your main class, like in this example, where you reference Apache Commons Lang 3 to use the string utils class. In that case, you still need to explicitly import the class and make sure that the jar file is at the right location. But you can go even one step further by importing the lang3 module instead of an individual class or package. That works as long as you do not have any class name collisions, that is the same class name in two different packages. Once again, why would you do that? In that case, the command line is a little more complex, as you need to import the module explicitly. First, you need to tell the compiler where is the jar that contains this module with the -- add module path option. And then you need to add it explicitly with the -- add modules option. Note that the application you are running is not itself in a module. So importing classes using this import module feature does not require your application to be itself a module application. I'm not sure that this is still a simplification since the command line becomes quite complex, but you can put these argument lines in a text file if you need to use this feature in a script-like application, for instance. This is especially useful if you have a lot of modules to import. So let me quickly wrap up this part because I actually showed you several relatively independent features. First, you can create an instance main method in a .java file that does not need to declare any class. Then you can launch this Java code without going through the compile phase. You can directly invoke Java and pass your source file. The JVM will compile this code in memory and run it. This code can now refer other Java code written in other files, and it can import other classes in the classical way, and also you can import modules directly. You can do that in any Java class, by the way, and you can do it even if your application is not itself a named module. If you need to learn more about these features, you can check the respective JEPs. As always, all the links are in the description. At some point, you will need to write some documents for your services, and the tool that Java has been giving you for years is the JavaDoc tool. It works well, it's rock solid, and it has been like that for years. It was chosen to use the HTML language for the JavaDoc, which was a good choice in 1995, but that was 30 years ago. I doubt that many people are still using HTML to write anything now. Usually you use some other markup language to generate HTML that is going to be rendered by your browser. So JavaDoc evolved, and now you can use Markdown to write the documentation of your Java services. Instead of writing this, which is the classical JavaDoc that you know, you can now write that, which is Markdown. When you need to use Markdown to write your documentation, all you need to do is to start the line with this // and the JavaDoc tool will interpret this group of lines as Markdown. And you can use any of the Markdown features that you need. Now, just take a look how it is beautifully rendered. Even the links will take you to the right classes or the right method. How cool is that? The last element I would like to talk about has to do with null values and constants in your Java code. And I would like to start this with a little quiz. What do you think this code would print? Let us analyze it for a minute, and you can pause the video and try to find that yourself. What you have is a class A with a method A that just returns a string containing A. Then you extend A with a class B, and what you want is to customize the A method so that it can return any string that you can pass as an argument to the construction of your B instances. And because you want to avoid null values, you declare this field final and initialize it within the constructor. Well, odds are that things are not going to work as you think they are going to work. If you run this code, sure, the construction of A is happening as you would expect it, but the construction of B exposes the A field when it is still null. What you are executing is the following. The compiler inserts a call to super in every constructor before anything else is executed. And by the way, you can put this call to super explicitly. And it is the case in the B constructor that is calling the A constructor before the field is initialized. So your code can observe two annoying things. The first one is that you can observe the mutation of a final field, which is obviously not exactly what you expect. It kind of breaks the point of being final. And the second one is the transition of this field from null to its final value. This is very annoying for null values. You can actually break any validation rule that you can imagine while you are constructing an object in that way. Where does this problem come from? Well, it comes from the conjunction of two problems. The first one is that the compiler inserts a call to super before the constructor from B is executed. So if you have some validation rules to check before constructing your object, well, you cannot execute them before this call to super. And this is very annoying because this call to super could be expensive, and what it did could be just thrown away in case your validation rule failed. And the second point is that the execution of the constructor A called the method from B, which was overridden, before B is constructed. This example is very simple and maybe a little funny, but this could lead to very serious issues. Suppose that instead of just displaying a value, A was actually computing some kind of hash code used later to sign the instance being constructed. Well, in that case, all your application could be at risk. So there are 2 points to fix. First, stop calling super implicitly as the first instruction of a constructor. And second, stop calling instance methods on objects that are not fully constructed. And there is some sneaky caveat also. First, you can observe uninitialized final fields, so you can observe their mutation. And second, it turns out that you can also mutate these final fields with the reflection API whenever you want. All this makes it impossible to create real constants in your Java application, which is bad because the JVM cannot optimize your final fields. It cannot seize them as real constants. If it could inline them, push their value where they are used, and make your application faster. There is some work done on this field. You can check the stable values preview features in the JDK 25 if you're interested in this topic. As usual, the link is in the description. And this is what the JEP 5.13 is doing. First, you still need to call the constructor of your superclass when you construct an object, but you can do it whenever you want during the construction process. So if you need to first validate the arguments you get, and second call this superconstructor if the validation is okay, now you can do that. And second, there are restrictions on the use of the this keyword in a constructor. In a nutshell, you cannot use this. The only case where you can use it is when you want to make a reference to an instance field to initialize it. And you can do that if they do not have their own initializers. Any other use of this is now prohibited. In particular, you cannot call an instance method on an object that is not fully constructed anymore, which is good. If you want to learn more about all this, don't forget to check the descriptions. I'll add links to other resources that you may find interested. And if you're interested to learn more about the other new features of the JDK 25, you can check the other episodes of this series again, see the links in the description. And with this, I'm out of coffee. So that's it for today. Talk to you soon.